So following on from some of the earlier videos, we've seen this binomial series. And we've established that this is exactly the same as this, but just written differently. And this is represented by this. So the whole series here can be rewritten as this, all the way to infinity. And then this thing here can be rewritten as this. So in this video, we're going to try and understand what happens when this n here, because n is moving from 0 all the way to infinity. We're going to try and understand what happens when n exceeds k, because k could be, let's say k could be 5, and then n is moving from 0 to infinity. So what does it even mean when you have this? Let's say 38, where this exceeds this. So that's what we're going to investigate in this video. But let me just give you a quick reminder. When n equals 0, you would put 0 into here and then into here. So k0 would be the utmost left one. So it's always going to be 1. So k0 will always be 1. So that's this one here. Well, if you put 0 into this n here, so x to the power of 0 would be 1. So when n equals 1, it will give you 1. And then when n equals 0, this whole thing here will give you 1. Now the next one will be when n equals 1. So put this into here. So that will then give you this, and then put the 1 into here. So that will then give you your k, this will then give you your k. And then when n equals 2, put the 2 into here, and then put the 2 into here. It will then give you this thing here, and so on. Look at the general term here. So when n equals 1, you would look at this. When n equals 1, it will give you your first block. When n equals 2, you would require 2 blocks. So require 2 blocks. That would then give you 2 blocks, because 1 block, 2 blocks. And when it's 3, you would look at 3 blocks. That would then give you 3 blocks, and so on. So you would then take that all the way to infinity. But then what happens when n exceeds k? So to try and understand what's going on, create a simple scenario. Let's just look at a case where k equals 3. Let's look at a case where k equals 3. So when k equals 3, your first term would be this. And then when n equals 1, you would put it into here. So that will then give you this, and then put the 1 into here. 3 choose 1 would be 3, and so on. That will then give you. Well, if you look at what's going on here, when this is 3 times 2, and then for your next term it would be 3 times, because if you look at what's going on up here, bear with me. If you look at what's going on here, you start with k, and then so in our case it was 3, and then you times by 1 less, which would then be 2, and then if you look at this, you times another 1 less, so that would be 1, and then you would then take it all the way to infinity. But then when if you keep on taking away 1, there will come to a point where you have 0, and then the next one will be -1, and then the next one will be -2, and so on. But the thing is, you've got this block, multiply with this, multiply with this, multiply with this, and there happens to be a 0 in this thing here. So the whole lot will be 0. So what I'm trying to say is that beyond a certain point, if you take n all the way to infinity, there will come a point where you will have a 0, and then 0 times the whole lot, it will be 0. So let's go back to this simple scenario. Where k equals 3. So it would be 3 times 2, and then the next one will be 3 times 2 times 1, and then the next one will be 3 times 2 times 1, and then 1 less than this will be 0. And then you can see that this whole thing here, because that's a 0 here, the whole thing here will disappear. And then when it comes to n equals 5, when it comes to n equals 5, it would be 3 times 2 times 1 times 0 times -1. Who cares about this? Well, you've got this 0 here, so the whole thing here will disappear. So here you would have plus 0, and then here you would have plus 0, and then let's look at when n equals 6. When n equals 6, put it into here, this will give you this. So when n equals 6, the coefficient will be 3 times 2 times 1 times 0 times negative 1 times negative 2 and so on. Well, you've got a 0 here. 0 times a whole lot, it will be 0. So here, the whole thing here will be 0. So you can pretty much here, you've got plus 0, and then here you've got plus 0, and then here you've got plus 0, and so on. So the point is, you only need these 4 terms. So your series will in a way come to an end, because you're going to plus 0, you're going to have something something something, plus 0 plus 0 plus 0. So you don't really, yeah, that's what your series will look like. Okay.